Next is photoelectric effect. We know that metals contains the free electrons, and these free electrons are responsible for the conductivity of the metals. These free electrons become free when they come out of their bonds and they move freely inside the metal. They cannot escape the metal surface because of the attraction pull from the ions inside the metal. So to escape from the metal surface, they requires the minimum energy, and that minimum energy is called the work function of the metal. This represented by phi 0, this is the work function, and this work function is the minimum energy required by the metal for emission of the electron from the metal. This work function depends on the 2 points. Number one, properties of metal, that is metal dependent, and another is the nature of the surface of metal. Different metals have different work function, that is the minimum energy required for the electrons to leave their metal surface. And as a broader range, the value of the work function is 5.65 electron volt for platinum, and this is the maximum value of the work function. Similarly, there is another metal which have the minimum work function, and it is for the cesium, and it is the minimum work function for any metal. This minimum energy can be supplied to the electron so that it can be come out from the metal surface in various ways. For example, one of the ways thermoionic emission, in which electrons comes out because of the energy is received in the form of the heat. Similarly, another is field emission, that means emission of the electrons from the metal surface due to the strong electric field. Third one is the photoelectric emission, and this will be discussed here. In the photoelectric emission, the metal surface is illuminated with the light of the suitable frequency, and that frequency should be greater than a particular minimum frequency, that is called the threshold frequency. Only in that condition, electron comes out from the metal surface, and the emission is called the photoelectric emission, and this is the point of discussion in this lecture. In photoelectric emissions, the electrons are emitted by the photosensitive substances which are illuminated by the light, and the electrons are called photoelectrons. And the current constituted by these photoelectrons is called the photocurrent. And this effect of emission of the photoelectrons due to the radiation falling on the metallic surface is called the photoelectric effect. For photoelectric effect, very important equation is given by the Einstein, and this equation is the photoelectric equation proposed by the Einstein is h nu equal to h nu naught plus k max, and this follow the conservation law of energy. Here h is the Planck's constant, and its value is 6.6 into 10 raised to the power minus 34 joule second. Nu is the frequency of incident radiation on metal surface. Nu naught is the threshold frequency for metal surface. That means if nu is greater than nu 0, only then photo emission takes place. If frequency is lesser than the nu naught, that is the threshold frequency, then the photo emission will not take place, no current will flow. And K max is the maximum kinetic energy of emitted photoelectrons. Therefore, we can say that this h nu is the energy of photon of incident radiation. This h nu naught is the phi 0, or we can say it is a work function of metal surface. Therefore, for emission of the photoelectrons, the energy of the photon should be greater than the work function of the metal surface. And this kinetic energy, that is the maximum kinetic energy, is the energy of the photoelectrons, which is the difference of the energy of the photon and the work function. And it can also be equal to EV0. Here is the charge on electron, and charge on electron we know it is 1.6 into 10 raised to the power minus 19 coulomb, and V0 is stopping potential. That means this potential is required to stop the electron, photoelectron, which have the energy K max, or the maximum kinetic energy. That means we can say K max is equal to EV0. There are some important points to note. For example, point 1 is that radiation which falls on the metal surface is composed of energy packets that called photons. And photons has the energy equal to h nu, or further we can write it is hc by lambda. Second point is intensity of radiation refers the number of photons incident on metal surface per unit area of the metal surface in unit time. This is the intensity. Note 3. If frequency of the incident radiation is greater than the threshold frequency, photo emission takes place and photocurrent constituted by these photoelectrons will be proportional to the intensity of radiation. But if frequency is less than the threshold frequency, no photo emission takes place, whatever the intensity is. That means intensity comes in the picture when photo emission is taking place. If photo emission is taking place, or we can say frequency is greater than the threshold frequency, in that case, increasing the intensity of the radiations means the number of the photons falling on the metal surface are increasing, and that will create more number of the photoelectrons emission, and because of that, photocurrent will increase. But if frequency is less than the threshold frequency, no photoelectric emission can take place. In that condition, if we increase the intensity also, then number of the photons falling on the metal surface increases, but these photons have the lesser energy than the threshold energy, and because of that, these photons cannot emit the photoelectron from the metal surface. And one more point is absorption of photons by metal surface and emission of electrons from metal surface is instantaneous. That means there is no time lag, or we can say approximately this time lag is very small, of the order of 10 to the power minus 9 seconds. So we can say absorption of photons and the emission of electrons are instantaneously, there is no time gap.